They want us to find a general solution, which means they want us to say y equals something, so that when you take the derivative of y with respect to x, it turns into this stuff. So you might be thinking, well, if I need something like above a derivative, I need the antiderivative, and you're on the right track if that's the case. So we call this type of differential equation a separable differential equation because you can move dx to both sides, kind of like multiplying dx to both sides. So you get dy equals all this stuff. Dx. And now, if we integrate both sides with respect to x, so I'm going to take an integral of both sides, finding an antiderivative of both sides. Actually, this side is with respect to y. This side is with respect to x, right? Because this says dy. So the integral of 1 with respect to y is y, right? Because if you were to take a derivative of this with respect to y, it'd turn back into what we had originally, this 1. You could put a 1 in front of there. And then the integral of this side with respect to x is what we've practiced with integration. Actually, this might be the first time we're seeing indefinite integration. Look, there's no limits of integration here, right? So there's actually going to be an infinite amount of solutions, and I'll show you why in just a bit. But let's proceed like normal. The integral is a linear operator, so the antiderivative of 3x squared, and then we can do the antiderivative here. The antiderivative of 3x squared is x to the third, because the derivative with respect to x would turn back into 3x squared. And then the antiderivative of secant x tangent x, that's secant x, because if you remember, the derivative of secant x is secant x tangent of x. But then we have to have something else here. We have to say plus some constant c. And the reason for that is, look, if you forget about the c, if you take a derivative, this turns into this, and we've got it, right? But what about if we said plus 1? The derivative of this does turn back into this. So doing plus 1 or minus 2 or plus 1,000, that doesn't change the fact that this is still the antiderivative, because the derivative of a constant is nothing. So we say plus some arbitrary constant c, and it's just a convention to use capital C for that arbitrary constant. But that's it. That's our solution to this exact differential equation.